Hi viewers, this is Sri Ramulu, DL in Physics. YouTube channel is s.s space physics. Please don't forget watch this video watching till the end and subscribing also. Now today's topic is transistor as an amplifier. What is amplifier? Amplifier means a device which can make the weak signal into strong signal. Okay, that is called transistor amplifier. Amplifying means its simple meaning is making strong or big, right? Now see the definition also given. The weak signal given to the input of transistor is amplified due to transistor action and produced in the output of the transistor amplifier circuit. Okay, so when weak signals are given to the input of transistor, what it can do, it amplifies, means it makes it strengthen the signal, means it make big in size or strong signal. And due to transistor action means forward bias and reverse bias, and produced in the output, and it shows at the output of transistor amplifier circuit. The process of raising the signal strength, here see, process of raising the strength of the weak signal without any change in its shape. So its shape should not change, but it must be strengthened. This is known as faithful amplification. That is a faithful amplification, means it must be strengthened and its shape should not change. Then only we call such a amplification is faithful amplification. Next, for faithful amplification, the following condition must be satisfied. What are the conditions? So when the amplifier satisfies these conditions, then that amplification is called faithful amplification. Here, proper zero signal collector current. So at the collector, zero signal has to present. Minimum proper base emitter voltage, means base voltage we must maintain minimum value. We should not maintain zero. We must maintain minimum value. Next, minimum proper collector emitter voltage. So that means output voltage we must maintain. Here collector current is 0, and base to emitter means it is a forward bias voltage, and here what collector to emitter means it is a reverse bias voltage. So we must maintain these two are minimum. The process or technique in which all the above three conditions are fulfilled is known as transistor biasing. That is called transistor biasing. Next, with the transistor biasing, base emitter junction is properly forward biased. Here see, base emitter always forward biased, and a collector emitter junction is properly reverse biased. See, like this, base junction is forward biased and collector junction is reverse biased. During the passage of signal, okay, while a signal is going, then only input section is forward bias and output section is reverse bias. This can be achieved by R1 and R2. See, what are the R1, R2? Let me show the diagram. It is a diagram. See here, R1, R2. VCC output voltage or collector voltage. It is here, we take output where here, R across RC. That appears here only. Okay, R1, R2. These are the important for making this transistor in proper biasing. Okay, it is a diagram. Next, right, RE act as a thermal stabilizer. Thermal stabilizer means while running a transistor, while amplifying a transistor, sometime it gets heated. So to stabilize its temperature, emitter RE means emitter resistance must be provided. So emitter resistance can make it can stabilize, means it make constant temperature. RC act as a load at output. See, RC can act as, means collector resistor it is, act as load at output. Next, the circuit used to provide biasing is known as biasing circuit. Which circuit provides biasing? That is called biasing circuit. For proper operation of transistor biasing is must. Okay, transistor biasing means input section is forward bias and output section is reverse bias. Next, figure explains how the transistor amplifies a weak signal. Okay, so that means this diagram. Okay, when a weak signal is given to the input of transistor, a small base current starts flowing in its base. When we give the small signal, then what happens? In the base, small current will flow. Okay, due to transistor action, a much larger AC current flows through the collector load RC. Just now I told you RC can act as a load at output. Okay, but due to the transistor action, when transistor is in forward bias and reverse bias, means in biasing condition, large AC current flows. Here AC current only, what we are doing here, this side at the input we give signal like this type of signal we have to give. Then we get a strengthened signal at output. Strengthen means if you give the like this small signal, at the output we get this much of. Okay, this is the diagram. Why it is like this? We give in this manner, but we get output like this. So why? Because this transistor has a characteristics. What is that? It can invert the input signal at output. Inverting means this side positive, this side at output it becomes negative, but it is strengthened, and this negative, this side is positive. So like this type of waveform we get. That means it introduces 180-degree phase shift. That means positive become negative, negative become positive. That is 180-degree phase shift. Now, this collector current is equal to the beta IB. Okay, why it is a beta formula? We know what IC by IB. Output current to input current. Input current is base current. Output current is collector current. So that is why beta IB is taken. A large voltage is produced across RC. Okay, here this point large voltage will produce. The RC value is quite high. Actually RC load it is act as a load, and it maintains a high value, high resistance value. Thus a weak signal given to the input of amplifier, it is amplified and produced at the output of the circuit. So when we give the weak signal here, then we get output amplified signal. Okay, like this. The gain of amplifier is defined as gain C, the ratio of output to input of the amplifier. Whatever output, why it is only giving simply output and input means gain may be in terms of current, in terms of voltage, in terms of power. So that is why in general form it is definition is given output to input. If it is a current gain, output current to input current. If it is voltage gain, output voltage to input voltage. If it is power gain, output power to input power. So that is why in general it is given like this. Okay. In an amplifier, we can have current gain, voltage gain and power gain. Gain what indicates? Gain indicate to us how much it is amplified. If you want to know how much signal is amplified, then you must take the either power gain, voltage gain, current gain or power gain. Okay, by using this you can estimate how much signal is amplified at the output, how much signal is strengthened at the output. Okay, so this is the front, and once again see the diagram. So in the examination, diagram is very important. RE, once again let me explain only diagram. R1, R2 are used to provide proper biasing. Proper biasing means input section is forward bias, output section is reverse bias. Next, RE is the emitter resistance. its main work is to stabilize it make a thermal stability for the transistor. Thermal stability means maintains a constant temperature. RC can act as a load resistance. Okay, and here we give the input signal. If you give this type of signal input, you can get output like this strengthened signal. It is strengthened. Okay, so this is why it is inverted means it has a property, it introduces 180-degree phase shift for the in between input and output. If it is positive, this side become negative, it is negative, this side become positive, like this it makes. So this is friend, don't forget watching this video till the end. Thank you.